Oh, hi grade 12. Shandises. Welcome to Science in 5. If this is your first time here, you might just want to subscribe. We've got a really lot of cool stuff for maths and physical science. In this video, we're going to discuss March test maths, basically term 1 maths. Let's go. But what's a shandis? What's that? Hello grade 12. Welcome to Science in 5. In this video, we're going to look at a grade 12 sample maths test for the March test. The topics covered in this paper are your algebra and equations, number patterns, trigonometry, and geometry. This paper that we're going to go through is adapted from the Gauteng Department of Education, Johannesburg North District, and it's a grade 12 test for March, April 2022. Okay. When you are revising past exam papers, as a rule, try to time yourself as well. Don't just go through papers. Make sure that you balance your time very well. Okay? Try to make sure that you balance your time very well. I would go with this rule: 1 mark per minute. Okay. So in other words, if a question is worth 4 marks, try to spend 4 minutes. If you go with that 1 mark, 1 minute rule, you'll find that it will actually help you to save time, and you can have time to check your answers as well. So it's very important that you also be able to check your answers. So, for example, the whole of question 1, if I just scroll through this, the whole of question 1, you discover that it's 25 minutes, right? And as a result, I need to spend about 25 minutes in this section. Okay, so as I go through this, I will explain as much as I can, but because I'm also trying to emphasize the time aspect, I also want you guys to learn the skill of passing within the specified time limit. Okay, so are we ready to roll? Okay, let's go. So the idea is you can pause the video at any time, time yourself, try a question, check the answer with what's happening. Let's go. Here is question 1.1. Solve for x. It's 2 marks, so it shouldn't be much of a hassle. Usually this is the factorization question where you easily find the factors and get the answer. So what you're going to do, I'm going to have x squared minus 7x plus 10. All of that is equal to 0. So which means I can quickly get my 2 factors from my binomial. Now I'm looking for 2 factors of 10 that give me 7 when I add or subtract them. It's 5 and 2. Place the 5, place the 2. The last term is a positive. You can only get a positive product when you multiply a positive and a positive, or a negative and a negative. But since the middle term is negative, it means here I must have a negative as well. So now, which means x is now equal to 5, or x is equal to 2. All right, let's move on. Now the next question, we're told to solve correct to 2 decimal places. What this usually tells you that is you are supposed to use the quadratic formula. So 3x squared plus 2x plus 6 equals 10. The equation is not in standard form. Let's bring it into standard form by just subtracting 10 from both sides. What's 6 minus 10? It's minus 4. And then all of that is now equal to 0. From here now I can quickly write on the side what my a value is. A is 3. My b value, b, is 2. My c value is now minus 4. So this is where the question was to try to catch you out, whether you can see that c is actually minus 4. Then let's go to the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So now all I'm doing here is going to be substituting. Okay, I know that the b is 2, so this is the same as minus 2 plus or minus the square root of b squared 2 squared minus 4 times the a value is 3 and the c value is negative 4. All of that is over 2 times 3. Okay, so by using a calculator, I can now easily simplify this whole expression. What's going to be inside the bracket is actually going to be the square root of 52. That's what the whole bracket simplifies to. So now I can actually have x is now equal to minus 2 plus the square root of 52 over 6, or x is equal to minus 2 minus root of 52 all over 6. This will now simplify to 0,8. Now the actual number is 0,86 something, but to round it off to 3 decimal places, it becomes 0,87, or x equals negative 1,54. Okay, are we still doing good for our time? I think we're still doing good for our time. So the idea is to try and solve this quickly. Once you solve this quickly, it allows you to actually check your answer. If you check your answer, you substitute one of these values into the original equation quickly, and then if you see that you're getting answer of 0, it means your answer is fine. Okay, so let's jump straight to 1.1.3, equations with exponents. Now 1.1.3, when you initially look at this equation, it can look very tricky, but it's not. You can see that there is x to the power of half, and then there is x again to the power of a quarter. Okay, initially when you look at this, there is no relationship. Is there a pattern there? Well, between the two exponents, which one is the smaller exponent? The quarter. Okay, so if you look at it, you can actually see that the x to the power a half is a product of x to the power a quarter times another x to the power a quarter. Why is that? Well, the law of exponents says if the base is the same, you're going to add the exponents. So if you add a quarter and a quarter, it will give you a half. All right, okay. So the first thing we could do, the first method you could try here is to try and factorize, because the first term seems to be coming from x to the power quarter and x to the power quarter. So I could say x to the power a quarter plus 3x to the power of a quarter minus 28 equal to 0. I can factorize. I can try factorize this. The first bracket, I'll have x to the power a quarter and x to the power a quarter. All right? Now, I need two factors of 28, but that will give me a sum of 3. Well, if I multiply two numbers that give me 28, I can have 7 times 4. 7 times 4 is 28. 7 minus 4 is actually 3. So I can put in a 7 and a 4. Now the middle term is positive, which means the larger term inside the bracket is the positive and the smaller term is the negative. So x to the power quarter plus 7 in bracket x to the power quarter minus 4, all of that equals to 0. All I need to do is now solve. X to the power a quarter is equal to minus 7, or x to the power a quarter is equal to a positive 4. Now when I get to this stage where I've got a rational exponent, how do I get rid of a rational exponent? Well, we have to use this idea of inverses. If I have the exponent 1 over 4, the inverse would be if I invert this whole expression. In other words, put the 4 on top and the 1 on the bottom. And notice that if you multiply a number with its inverse, the product is always 1. So that is the trick I'm going to use here. I want to multiply a quarter with its inverse so that I get 1. But remember, it's an exponent. So basically, I need to raise it to the power of 4. So what I'm going to do is to say x to the power a quarter, all of that raised to the power of 4 is equal to minus 7 raised to the power of 4. Whatever I do on the left-hand side, I do on the right-hand side. Or I can say x to the power a quarter raised to the power of 4 is equal to 4 to the power of 4. Okay. So x to the power a quarter raised to the power of 4, one of the laws of exponents says multiply these exponents. A quarter times 4 is 1. So I'm going to remain with x equals minus 7 to the power of 4. A negative number raised to a positive exponent will give me a positive number, 2401. And then here I also get x is equal to 256. Okay. This is one way of solving this problem. Okay. This is one way of solving the problem. Actually, try to treat it like a binomial. In terms of factorization, I can get a binomial from this expression and then solve it like how I normally solve a simple quadratic equation. Either one of the factors is 0. Okay. The other method I'm going to use is called the K method. Now with the K method, again, I have to be able to look at the smallest exponent and see if there is a way it is linked to the bigger exponent in the equation. So I've already discovered that x to the power a half is actually the product of x to the power a quarter and x to the power of another quarter. With that information, I'm going to say let k be equal to the smaller exponent is x to the power a quarter. So whenever there is x to the power a quarter, I'll substitute it with k. So the first term, the x to the power half, is actually k times k now. So I'm going to have k squared plus 3 of k minus 28, all of that is equal to 0. Now I can simply get two binomials from this expression. I don't know why I got 38 there. It's 28, right? So again, two factors of 28. We discovered the factors were 7 and 4. It was a positive 7 and a negative 4. All of that is equal to 0. So k equals minus 7 or k equals a positive 4. But remember what k is. K is actually x to the power of a quarter. So x to the power a quarter is now equal to minus 7, or x to the power a quarter is equal to 4. We've already talked about how to deal with rational exponents. Raise them to the power of the inverse. Okay, first find the inverse of the exponent, then raise both sides to the reciprocal of that, okay, or the inverse of that exponent. So we now know that x is now equal to 2401 or x is equal to 256. Which method do you prefer, the K method or factorizing? Okay. Again, if you get time, please check your answers for equations. It's always good. How you check? You just substitute where there is x. You can just say, let's say for example 2401 to the power of a half plus 3 times, remember it's 3 times, not 3x to the power of a quarter, it's 3 times 2401 raised to the power of a quarter minus 28, and see what does the calculator tell you your answer is. Okay. I'm just going to check in case I made a mistake. 3 times 2401 raised to the power of a quarter and then minus 28. I'm getting the answer is 0. Okay. So, which means my sum is correct. So the answer is 0, so which means 2401 is an answer. You can also check with 258. See if your answer comes to 0 on the left hand side. If your answer is coming to 0 on the left hand side, then it means that your answer is actually correct. Okay guys, moving on to the next question. Question 1.1.4. At any point you feel like taking a break, do take a break. Okay. 1.4, we've got an equation with a surd. Okay. So the equation with a surd, what do we do with the equation with a surd? We need to get rid of the surd. Okay. The only way we can get rid of the surd is by squaring both sides. So we're going to have 2 minus x, there's a square root sign, equal to x minus 2. Square both sides. The 2 minus x is now 3, but the x minus 2 has to be squared now. Okay. And then the 2 minus x is now equal to what? At this stage, you should be able to square a binomial in one step. Okay. Square the first term, x times x, x squared. Multiply the two terms inside. x times minus 2. And then multiply that by minus 2, you get minus 4x. Squaring minus 2 times minus 2 gives you a positive 4. Now, simplifying this, what we can get is, let's subtract 2 from both sides and add an x. So on this left hand side, we want to remain with 0. So what we're going to do on the right hand side, well, the 2 becomes a negative 2. So we're remaining with x squared minus 3x plus 2. Okay, now we can factorize easily again. 0 equals, open brackets, x. There's another x there and that. Again, you can see that the last term is positive, the middle term is negative. So both our factors must be negative. Product of 2, giving you sum of 3, it's going to be 2 and 1. Now we can see that, x equals 2 or x equals 1. The trick now with equations with surds is we can't just run away from our answer, we have to check the solution. In other words, if you substitute 2 where there is x, you get the same result. Okay, so for example, if I say 2 minus 2 is equal to 2 minus 2, I get 0 equals 0. So x equals 2 is fine. But if I check, let's check with 1. If I say 2 minus 1 is equal to, what's 1 minus 2 minus 1? I get 1 is equal to minus 1, and this is not the same. So we have to reject x equals 1. So we reject x equals 1. And the answer is now x equals 2. You've got to check the answer for equation with surds. Just to remember, I have to check the answer. Once you check the answer, simple, reject the answer that does not make your equation balanced. In other words, the left-hand side is not equal to the right-hand side. Moving on to question 1.2. For which values of k will the equation have real roots? So when you talk about the nature of the roots, there's something that you need to quickly gravitate towards. Remember, we said in the quadratic formula, x is minus b plus or minus the square root of b squared minus 4ac all over 2a. If you focus only on this expression here, the b squared minus 4ac, we call that the discriminant. In other words, the value of that term will determine whether the roots are real or non-real, or they're rational or irrational. Okay, so we have to identify that. For real roots, what does that mean? It means we need at least 0 in there. The number must not be negative. It must be 0 or greater than 0. So, simple language, we need b squared minus 4ac to be greater than or equal to 0. That's the first thing. Okay. Then now when you look at our equation, it's given in terms of x and k. Not a problem. We need to still figure out what a is, what b is, and what c is. So once we figure out this, it means we can substitute into this expression, and then usually it becomes an inequality that you need to solve. Now there's a trick there. Look at it. The a value is easy to see, 3x squared. The middle term, the one that has got bx, there's a bit of a trick there. It looks like there are two terms. There's kx, there's minus 3x. But what if I simplify the middle terms, factorize? Okay, I would end up with 3x squared. I can factor out a positive x there, right, plus x. What will remain is k minus 3, and then minus k. In other words, I always want the equation to look something like the expression to be ax squared plus bx plus c. Once it's like this, it's easier to see what the a, the b, and the c are. So now I can quickly easily identify there's the a, there's the b value, the coefficient of x, and there's the c minus k. So all I now need to do is to substitute. B squared is k, b is actually k minus 3. Okay, so just say a equals 3, b is now k minus 3, and c is minus k. So figuring out that b is k minus 3 was the key step here. Otherwise, the b squared minus 4ac becomes difficult to simplify. So let's run with b squared minus 4ac, also called delta, the discriminant. Okay, b squared is k minus 3 squared minus 4 times a is 3, and c is minus k. Again, be very careful of this last term c. It could be a positive, it could be a negative. In this case, it's a negative k. Square binomial again. Notice how this trick of squaring a binomial has come back handy again. So, grade 12, you've got to practice squaring a binomial in one step. At this stage, you cannot be foiling, breaking it into 2 brackets and foiling. That will eat up time unnecessarily. Square the binomial, let's move. K times k, k squared. K times minus 3 is minus 3k. but there will always be another minus 3k. So which is the same as minus 3k times 2 gives us minus 6k. Minus 3 times minus 3 becomes a positive 9. Now, what's minus 4 times 3 is minus 12. Minus 12 times minus k becomes a positive 12k. And all of this is now greater than or equal to 0. Okay. Now, simplifying this expression, minus 6k plus 12k is a positive 6k. So I end up with k squared plus 6k plus 9 is greater than or equal to 0. I can easily factorize this. Okay, what are the factors? Well, this is an example of a perfect square, because once you factorize this, you discover that 3 times 3 is 9, 3 plus 3 is 6. So I'm going to have k plus 3 or k plus 3 squared greater than or equal to 0. Right? Now, to get the solution to this, okay, it means what? If I was to solve an equation, this equation is an equation, k plus 3 squared equal to 0, my answer would be k is equal to minus 3. So in other words, the critical value is minus 3. So therefore, I can now say k is greater than or equal to minus 3. Notice in this time around, I did not divide or multiply by negative, so I don't need to change the sign. One of the tricks as well. All right, so to understand the nature of the roots, you have to understand the discriminant b squared minus 49. B squared minus 4ac. I'm thinking of 49. B squared minus 4ac from the quadratic formula. We call that the discriminant. And once you know what b squared minus 4ac is, you can actually determine the nature of the roots without even solving the equation. So this type of questions, they don't want us to solve the equations. They want to use an algebraic technique to see whether the roots are real or they're non-real or they're rational or irrational based on b squared minus 4ac. Okay. We're moving on to question 1.3. It says solve for x and y simultaneously. Well, they don't say it, but it's a simultaneous equation. How do I know it's a simultaneous equation? I've got two unknowns and two equations. All right, so the first thing we want to do with this type of equation is to try and make a third equation where we have made one of the variables the subject of the formula. In other words, we want to be able to substitute. I will take this equation that has got no exponents. Because if you look at the second equation, there is exponent, x squared, y squared. So working with this can be a little bit tricky, but take that one. Let's make the x the subject, right? So if I have 3y plus x equals 5, I can end up with x equals 5 minus 3y. And that can be my third equation, right? So what I'm going to do now, I'm going to say sub x equals 5 minus 3y into the first equation, okay? Into this equation, x squared plus y squared equals 100 plus 5y. So where there is x, let's put 5 minus 3y. Okay, looks like this is going to be a long road of algebra. It's not necessarily hard, but just a little bit long. So please don't make mistakes. Try to improve your accuracy. So let's start. So where there is x, we have 5 minus 3y. So it's 5 minus 3y squared, we'll be squaring a binomial again, plus y squared is equal to 100 plus 5y. Let's square the binomial. 5 times 5, 25. 5 times minus 3y minus 15y times 2 minus 30y. Negative 3y times negative 3y, a positive 9y squared plus another y squared equal to 100 plus 5y. Again, don't lose the sum, follow the sum. Once we've got an exponent greater than 1 or exponent 2 or the highest exponent, we want to write that first. 9y squared plus y squared becomes 10y squared. I've got negative 30y on the left hand side, but I've got 5y on the right hand side. If I subtract 5y from both sides, I'll end up with negative 35y, but here I've subtracted the 5y, so it goes. Now I'm left here with the 25 and 100. If I subtract 100 from this side, I must subtract 100 from this side as well. So this becomes minus 75 is equal to 0. I need to solve this equation. How would I solve this equation? Maybe if I divide this, it seems like the first term is 10, second term is 35, 75. These are all divisible by 5. Okay, so if I divide 10 divided by 5 is 2, 2y squared. Negative 35 divided by 5 is negative 7. Negative 75 divided by 5, negative 15 equal to 0. Okay, I can try to factorize this sum. If I can't factorize, then I'll have to use quadratic formula. But can I factorize? Well, the first term should be a 2y in the first bracket. Second bracket should be y. All of that is equal to 0. The last term is 15. So I'm looking at numbers like 3 times 5 or 15 times 1. Okay, because the coefficient of y squared is not 1, I'll take a little bit longer to find the factors, but it's okay. All right, so if I try 15 and 1, most likely 15 and 1, it'll be difficult to get 7 from 15 and 1. So I'm going to lean towards the 3 and the 5. Okay, how do I put the 3? Where do I put 3? Where do I put 5? Well, if I'd say, let me put 3 and 5 here. Remember, the middle term is going to be found by multiplying the 2 and the 3 and dealing with the 5 and the y. Okay, so 2y times 3 is 6y, 5 times y is 5y. What can I get from 6y and 5y? Can I get 7y from that? There is no way of getting that, so I have to swap these numbers inside the bracket. So 3 and 5 will not work. What if I put the 5 there and then the 3 like that? Inshallah, I put the 5 and the 3. I can get 2 times y times 5, I'll get 10y. 3 times y will get 3y. Can I get 7y from 10y and 3y? Yes, 10y minus 3y will give me 7y. But even because I want a negative 7y, I'll have negative 10y plus 3y. So to get a negative 10y, it means I'll have to have negative 5, and there I put a positive 3. Okay, I'm using more like a trial and error technique to get the factors. Okay, you also use a trial and error technique to get the factors. From here now I can easily solve. I can see that here y is equal to 5. How would I solve this? Well, 2y plus 3 is equal to 0. Move the 3 across, it becomes negative 3. So I'll end up with 2y equals negative 3. Therefore, y must be minus 3 over 2. So I've got two values for y. Y equals minus 3 over 2, or y equals 5. Which means I must also have two values for x. Now to get the x values, is simple because I've already made an equation. This equation becomes very handy to help me get the value of x. X equals 5 minus 3y. So all I'm doing now is substituting. So y equals minus 3 over 2. So x is now equal to 5 minus 3 times negative 3 over 2. This becomes 19 over 2. Just use a calculator. 19 over 2. So the 19 over 2 did not come right there. So 19 over 2. Or x is now equal to 5 minus y equals 5. So it's going to be minus 3 times 5. This simplifies to minus 10. So I've got y equals negative 3 over 2, y equals 5, x equals 19 over 2, or x equals negative 10. Again, you can check these answers to see if they work. The trick is, if you're going to use the 3 over 2, it corresponds to which x value? The 19 over 2. If you're going to use the x equals minus 10, make sure you link it with the y equals 5, like that, when you're checking your answers. Question 2, we're looking at a number sequence. Consider the sequence 1, 4, 11, 22, 37. They don't tell us what type of sequence it is, so we have to figure out what type of sequence this is. Okay? So, 1, let's use blue. So 1, 4, 11, 22, and 37. Let's see the difference between these terms. 1 and 4 is 3. 4 and 11 is 7. So this cannot be an arithmetic sequence. Okay? 11 and 22, there is 11. 22 and 37, there is 15. Again, it's not a geometric sequence. We don't have a common ratio. Common ratio, if I say 7 divided by 3, 7 over 3, I would check if it's equal to 11 over 7. It's not equal. So, it's not a geometric. The only way I can do this, let's look at the second difference. 7 minus 3 is 4. 11 minus 7 is 4. 15 minus 11 is also 4. So the second difference is common. So this is quadratic. So sometimes examiners can just give you a sequence and they want you to figure out whether it's a quadratic sequence, it's an arithmetic or linear sequence. So we have discovered it's a quadratic sequence, and we discover the second difference is 4. Okay? Now, how do you get the nth term? Well, the general formula for a quadratic sequence is Tn is an squared plus bn plus c. So we need the values of a, b, and c. Okay, how do we do that? Well, the value of a is easy. Okay, you always say the second difference divided by 2. Or you can just say 2a is equal to 4. So this means a is equal to 2. So we've got the value of a is equal to 2. Now, how do we get the value of b? Okay. So normally this technique it's called the ABC method. Get A, get B, get C. How do you get the value of b? Well, to get the value of b, you're going to have to say 3a plus b is equal to what? Is equal to the first difference of the terms. Okay, so let's do it this way. So we know that from 1 to 4 to 11, first difference is 3, and then the first difference is 7. That's how we ended up with the 4. Okay, so 3a plus b is equal to 3. Well, since I'm explaining, I can just quickly explain where the 3 plus b comes from. What is the idea of this 3a plus b, and why is it equal to the very first difference here? Well, if I substituted into this general expression Tn equals that, I would get T1 being equal to, n is going to be 1, so T1 ends up being a plus b plus c. So in other words, the first value 1 in the pattern is actually a plus b plus c. Okay, what about the second term, the 4? Well, it means n is now 2. So where there is n, put 2, you're going to get 4a plus 2b plus c. So T2 is 4a plus 2b plus c, T1 is a plus b plus c. Now, if I said 4 minus 1, I got 3, which will be the same as T2 minus T1. If I say T2 minus T1, I would subtract 4a minus a gives me 3a, 2b plus b gives me 2b minus b gives me b. And this is now equal to the 3 there. So just remember that 3a plus b is equal to that, and then you can continue. So in other words, sometimes it's always useful even to take this like that, right? And then on the side, you can actually say, well, I know that 2a can actually say, put the 2a is equal to 4, and then I'm going to say that 3a plus 3b is equal to 3, and then a plus b plus c is equal to 1. So if you remember it like that, and you can solve this expression starting from the bottom. Once you know what a is, you can get what b is. Once you know what b is, you can get what c is. Okay. So that is the easiest way of remembering it. That's why I call it the ABC method. Okay, get a, get b, and get c. So from here we can now easily get what b is, because we know that a is equal to 2. So 3 times 2 is 6. 6 plus b equals 3. So I'm going to have 6 plus b equals 3. So b is now minus 3. So I've got a equals 2, b equals minus 3. The last step, so this was my first step. That was my second step. Now the third step is to do the a plus b plus c equals 1. In other words, 2 minus 3 plus c equals 1. Solve this little equation, I get c equals 2. Once I've solved that c equals 2, I now know what a is, what b is, and what c is. I just come in and say Tn equals 2n squared. The b value is minus 3, minus 3n, and the c value is a positive 2. Very easy to master this ABC technique. Remember, the 2a will be the second difference. So once you write the terms like this, 3 terms, 2a is the second difference, 4. 3a plus 3b is the first difference, 3. A plus b plus c is equal to the very first term. and we use that to solve that problem. Which term has a value of 407? So we know that 407 will be the value. We don't know what n is. So basically, we're going to solve this equation. Normally for this type of equations, the factorization can be a little bit tricky. That's why I will say quickly simplify to a quadratic equation. You can even use a quadratic formula and you get your answer quickly. But if you're comfortable with factorization as well and you're sure you can find the factors, do that as well. So we're going to end up with 0 on this side. We have taken the 407 across. It's going to become a negative 405. So if I was to use the formula, I can see that my A value is 2, my B value is minus 3, C is negative 405. So to use the formula, we say n, but normally we use x, but this time we can also use it for n. So we can actually say n equals, what is the b value? Minus 3. So it's going to be 3 plus or minus the square root of b squared minus 4ac all over 2a. Okay. Now, in this case, the b value is minus 3. So I've got 3 plus or minus square root of negative 3 times negative 3 becomes 9, minus 4 times 2 times negative 405. All of that is 2 times 2 is 4. So grab a calculator and say, put all those digits into the calculator. You get the square root actually simplifies to 57. Okay, simplifies to 57. So this becomes 3 plus or minus 57 over 4. Since we are looking for a term of the sequence, we're going to ignore the negative number. The negative number will come when you say 3 minus 57. You see that, guys, there? From this expression, if I say 3 minus 57, I'm going to get a negative number. So let me focus on the positive. So n equals 3 plus 57 all over 4. 60 over 4 is 15. Okay, so I can ignore the negative number. And then n is not equal to the 3 minus 57 over 4. We'll ignore that number. Okay, so it's the 15th term. The 15th term in this sequence has got a value of 407. 2.2 says how many terms are in the following arithmetic sequence. We want the number of terms. It looks like this is the last term. So this is term 1, term 2, term 3, term 4. Whatever 202 is, that is the number of terms that we've got in this expression. So normally we use the formula Tn equals A plus n minus 1d. And for arithmetic sequences, this formula is easy to work with because we focus on the value of A and if you can get the d. In this case, the A is given as 40. And what is the common difference? We're adding 6 each time, so the difference is 6. Okay, so now all we need to do is to substitute. 202 is equal to A is 40 plus n minus 1 times 6. All right, and we can now easily solve this equation. Subtract 40 from both sides or move the 40 across. You end up with 162 multiply 6n minus 6. You end up with 168 equals 6n. Divide both sides, you get n equals 28. Question 4. The fourth term of an arithmetic sequence is minus 3 and the 20th term is minus 35. Determine the common difference in the first term. Well, we know that the fourth term, if I look at the general term, I say Tn equals A plus n minus 1 d. The fourth term, n equals 4. 4 minus 1 is 3. So basically T4 is equal to A plus 3D, and T20 must be equal to A plus 19D. We already know the values of T4. So instead of writing this, we can actually write the values of T4. T4 is minus 3 and T20 is minus 35. Does this look like a system of linear equations? No. But simultaneous equations? Yes. Two unknowns, two equations. So this is actually equation 1. That's equation 2. The simplest way I can do this to subtract these two equations, because I can see that one of the coefficients is 1 on the variables. Okay? So I'm going to say subtract 1 minus 2. In other words, subtract equation 1 from equation 2. So, which means on the left-hand side, I'm going to have minus 3 minus 35 being equal to, the a's are going to cancel out. I'm going to cancel out the like terms, and then I'm going to have 3d minus 19d. Okay? So, what is minus 3 minus 35 becomes a minus 3 plus 35, gives me 32. 3d minus 19d is negative 16d. Dividing both sides by negative 16, I get d equals minus 2. Once I get the value of d being equal to minus 2, I just choose any one of these equations, substitute the value of d, and I can get what a is. So, for example, I'm going to say minus 3 is equal to a plus 3 times minus 2. Minus 3 times minus 2 becomes minus 6. Minus 6 across becomes a positive 6. So a is 3. So there are my answers there. A is 3 and d is negative 2. I just formed two equations with two unknowns. Solve those equations by what? By subtracting them. You can actually subtract a system of linear equations if the variable in both equations is 1 for one of them. So for example, in this case, the a had an exponent of coefficient of 1 and a coefficient of 1. So if I subtract these two equations, actually I can subtract the a's. I can get rid of the a's. Make sure you order which way you want to subtract. In this example, I used equation 1 minus 2. You could also say equation 2 minus 1. It should give you the same thing. Think about it. If you were to say equation 2 minus 1, the 19d minus 3d would give you the 16D, and is equal to the negative 35 minus minus 3 will give you again minus 32. And you still end up with D equals minus 2, and you'll find that A equals 3. Okay, so when it comes to subtracting the equations of this technique, it doesn't matter which one you subtract. You can say 1 minus 2 or equation 2 minus equation 1. Effectively, the algebra should lead us to the same answer. Okay. The second question says evaluate. There we've got a sigma notation, sum of terms from k equals 1 to 20, and it is a pattern formed by a formula 3 to the power of. Usually when you see the formula that says 3 to the power of, this is a geometric pattern. Now how do you add the sum of terms for a geometric pattern? The sum of terms, you need the a value, r to the power n minus 1, all over r minus 1. So for us to be able to add these, we're going to need two things, the a value and the r value. So when it comes to geometric terms, and you're using the formula, you'll notice that you always need the a value and the r value. For the quadratic pattern, we said you need the a, b, and c value. And for the arithmetic pattern, you need the a and the d value. So if you always think of your patterns like that, it becomes easier. So how are we going to get a and r? Well, to get a and r, usually it's easy if you've got T1, T2, and T3. T1 becomes a. If you divide T2 over T1, should be the same as T3 over T2. That's how we're going to get r. So r is T3 over T2, which is the same as T2 over T1. Can I generate T1? Yes, I've got the formula. So T1, where there is k, I'm going to put 1. So T1 is actually 3 to the power of 1 minus 2. T2 is going to be 3 to the power of 2 minus 2. And T3 is going to be 3 to the power of 3 minus 2. This simplifies to 3 to the power of 1 minus 2 is 3 to the negative 1, which is the same as 1 over 3. This becomes 3 to the power 0, which becomes 1. This becomes 3 to the power of 1, which becomes 3. So now I can see that my a value, there is my a value, there is a. My r value is 1 over 1 over 3, or it's 3 over 1. So my r value is actually 3 over 1, which is 3. Once I've got a and r, now I can substitute in the formula for the sum of 20 terms. We need the sum of 20 terms. Sum of 20 terms is now equal to a is 1 over 3 into r, 3 to the power of 20 minus 1 all over 3 minus 1. We get a very, very, very large number. Okay. 5811,307,33,3. I wonder if I could read this number out. Listen carefully. Listen carefully. All right. If I divide by 3 there, then I divide, I count 3, put a comma, 3, put a comma. Okay. I see that this number looks like it's 508 581,130,733,3. Listen carefully. 581,130,733,3. Okay, that is the answer. Now, 3.3, we are told that the following sequence forms a convergent geometric series. So guys, for a convergent geometric series, we know that the R value must be between -1 and 1. It must be there. It's usually a fraction, negative fraction or positive fraction. Okay, now we are asked to determine the possible values of x. What if we found out what R is, and then we just substitute into this expression and see if we can solve that quadratic inequality? Generally, we know that R is the same as T. We've got T1, T2, T3, and T4. So R can be T4 over T3, T3 over T2, T2 over T1. Okay? They should give us the same ratio. So I'm going to work with what? What am I going to work with? I'm going to choose to work with any of these ratios, okay? T2 over T1. The T2 over T1, the T2 value is 1 over x minus 1. When you're dividing expressions, I normally prefer to write the division sign like this. Don't make the sum very complicated. The T1 value is 3 over x minus 1 squared, right? So we know that when we have division of fractions, what can we do? Convert division sign into multiplication and invert, flip that fraction, that rational term upside down. So the x minus 1 squared goes on top, the 3 goes to the bottom. Okay. The x minus 1 squared we can divide across, so this exponent goes, that one goes, and then I remain with x minus 1 over 3, like that. So R is x minus 1 over 3. So now to feed it into that, I'm going to have minus 1 less than x minus 1 over 3 less than 1. Get rid of the 1, of the denominator 3. You end up with minus 3 is less than x minus 1 less than 3. How do we get rid of this negative 1? We're going to have to add 1 on the left and on the right. So if I add 1, I end up with minus 2 less than x less than 4. So in other words, the value of x is any number between 2 and 4. Okay, so this is my final answer. All right. Then if x equals 2, calculate sum to infinity. We know that the sum to infinity, what is the sum to infinity? Well, the sum to infinity is equal to a over 1 minus r. So what is the a value when x equals 2? Well, the a value is going to be 3 over 2 minus 1 squared. 2 minus 1 is 1, so the a value is going to be 3. And then the r value, because we also need for the sum to infinity, what will be the r value? Well, we need to know what the second term is. So T2 is going to be equal to 1 over x, or rather 1 over 2 minus 1, which is 1. R is T2 2 over T1, which is 1 over 3. So I've got A and R. So this formula, now I can basically continue this formula, which is now gives me 3 over 1 minus 1 over 3. So 3 divided by 1 minus 1 over 3 gives me 4.5 or 9 over 2. Okay, so for this stage, we've looked at the algebra and equations, and we've looked at the sequences and series. Hope you learned something about the ABC method and what to look for in an arithmetic pattern, what to focus in a geometric pattern. In part 2 of this video schedule, we're going to look at the trigonometry and the geometry. I'll see you guys around next time. Thanks for watching. Please don't forget to subscribe, like, and share this video.